And the question we're trying to answer is, how do we prove that a quadrilateral is a parallelogram? So we want to know how much information, what's the minimum amount of information that we need to know that if we have a quadrilateral, a four-sided shape, that four-sided shape is a parallelogram. So that's what this first side of our sheet is all about. So our first one tells us that if we have two pairs of opposite sides of a quadrilateral, we're starting with a quadrilateral, we don't want to know if it's a parallelogram. If two pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. And on our picture, two pairs of opposite sides, what we're saying is those two are congruent and those two are congruent. So that's what it would look like in symbols. We could also say that segment AC is congruent to segment BD, and segment AB is congruent to segment CD. So we have two pairs of opposite sides that are congruent. That guarantees us that that quadrilateral is a parallelogram. All right, we good there? That's one way we can figure it out. That's one way we can prove it. The next one tells us if an angle is supplementary. And what does supplementary mean? Adds to 180. To both consecutive angles. The quadrilateral is a parallelogram. So we could do this with any angle and its two consecutive angles. So I'm going to do it with these two. So what we're saying is that the measure of angle B plus the measure of angle A equals 180, and the measure of angle B plus the measure of angle D equals 180. So both pairs of consecutive angles. And I could do it with any set. I just chose that particular. That's enough information to guarantee us that our quadrilateral is a parallelogram. All right, we good there? All right, let's look at the next two. I'm going to grab those. So there's our next pair. And again, we're starting with quadrilateral here. We're starting with a quadrilateral. We want to show that it's a parallelogram. So this one says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So if we mark that on our figure, we would have something like this, and something like this. And if we were to write it out, we'd say that angle B is congruent to angle C, and angle A is congruent to angle D. That would be enough information to guarantee us that this quadrilateral would be a parallelogram. Both pairs of opposite angles are congruent. We're good on that one. All right, the next one says if the diagonals bisect each other, then the quadrilateral is a parallelogram. Now the diagonals, what do we mean by the diagonals? Where are the diagonals? A line between the corners. We're going across the quadrilateral. There's one diagonal and there's another diagonal. And I'm going to mark this point M. All right, so there are lots of ways that we could say that the diagonals bisect each other. You could see something like segment AD bisects segment BC, and segment BC bisects segment AD. That would say they bisect each other. It could also say that M is the midpoint of both segments, AD and BC. The figure could be marked so that these are congruent and these are congruent. That would tell us that this point is right in the middle of both segments. So in order to figure out if this quadrilateral is a parallelogram, we could figure out that the diagonals bisect each other. All right, questions on that one? Okay, let's look at the last one. The last one tells us if one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. So what we're saying there, I could pick either pair of these, but we want them to be parallel, so we have something that tells us they're parallel, and we want them to be congruent, so we have to have something that tells us they're the same. We could say AC is parallel to BD, and AC is congruent to segment BD. So one pair being congruent and parallel is enough to show us that we have a parallelogram. So we have 5 different ways we can figure out if a quadrilateral is a parallelogram. And then tomorrow, or next time, we'll work on the other side. The other side is all about if we have a parallelogram, how can we figure out if it's a rectangle, a rhombus, or a square? That's what we'll do next. All right, questions on these conditions, these ways to decide if our quadrilaterals are parallelograms. All right, what I want to do next is go through some examples of how we might use this information to solve different kinds of problems. So the examples, there's not room for the examples on your sheet. So the example should go on a separate sheet of paper. All right, so here's what we're going to start with on this one. All right, and we're going to say that this is our STU. And the question is, all we know is that this is a quadrilateral. The question is for what values of x is our STU a parallelogram? Well, in order for it to be a parallelogram, what has to be true about the opposite sides? They have to be the same. So pairs of opposite sides have to be the same. So we need x plus 8 equals 5y, and both pairs of opposite sides have to be the same. 4y minus 3 equals 2y plus 5. We need both of those to be true. Well, now we have two sets of equations. We have an x and a y. So what do we do to solve a set of equations like this? Put one into the other. We want to solve one, so we have the one of the variables by itself, and then substitute it into the other. That's exactly right. So I'm going to start working with this one, because this one only has a y in it. So that'll let me find what y is. All right, so I'm going to subtract 2y. So 2y minus 3 equals 5. I add 3. And I get 2y equals 8, divided by 2. And y equals 4. And the problem said for what value of x? Well, now I'm going to take that y equals 4, and I'm going to plug it in right there. So that, when I do that, I get x plus 8 equals 5 times 4. So x plus 8 equals 20. Subtract 8, and x equals 12. And there's our answer. If x equals 12, that's going to make these opposite sides, both these opposite sides, congruent, and we would have a parallelogram. We did something like this last night, and there's some more in our homework today. All right, questions on that example? All right, for the rest of these, for all of these, we want to know, can we say that, let's do it this way, is the shape a parallelogram, and why? So here's my shape, and I need to mark it up. All we know is that this is a quadrilateral. So these, we can't go by what it looks like. We have to go by the information that they give us. All right, what did I just draw there? I drew the diagonal. So this question might have something to do with diagonals. All right. So is this shape a parallelogram? Yes. Order says yes. Why?
Because they bisect.
Diagonals bisect each other. Each of the diagonals is cut in half right there. The diagonals bisect each other, so this is going to be a parallelogram. That one was nice. Questions? Questions on that example? Now, not all the problems are going to be, is this a parallelogram? Sometimes we have to decide the shape as a parallelogram and then use that information to do other things. Then we would know that if we knew this is a parallelogram, we know that the opposite sides are parallel. We would know that the consecutive angles are supplementary. The opposite angles are congruent. So we might need to use that information then to figure something else out. So this could be just the first step in some other problem. But it's nice when we can figure out a shape as a parallelogram because that gives us a lot more information about our shape. All right, is this shape a parallelogram? I hear a couple of yeses.
Yes.
And what would be our reason? Now, is it enough to have one set of opposite angles congruent for it to be a parallelogram? No, we have to know both sets. They're supplementary. Each pair is supplementary. So if I add these two together, 131 plus 149 equals 180. 131 plus 49 equals 180. So I have two pairs of consecutive angles supplementary. So because those two pairs of consecutive angles are supplementary, that tells me that this shape is a parallelogram. All right, hopefully this last one's easy. Is that a parallelogram? Yes? And why would that be a parallelogram? Two opposite sides congruent. Two pairs opposite sides congruent. So these are the kinds of problems that we would use this information for. Like I said, not always is the problem just to decide if it's a parallelogram, but then maybe to use the idea that it's a parallelogram to figure some other things out that the problem might be asking. But this is how we can decide if a quadrilateral is a parallelogram. All right, questions? Okay, we will do the next side of the graphic organizer next time. So our homework for tonight. There we go.